Good day, sir. Our topic for the final presentation, which is the example calculations of sextant altitude by stars and planets. So, this is my members, Group 3, the Cadet Barliso, the Cadet Zosimo, the Cadet De Los Santos, and the Cadet De La Torre. So, the learning outcome of this topic is after the discussions, the student should understand the calculations about the sextant altitudes by stars and planets. So, next is what is a sextant? So, a sextant is a doubly deflecting navigation instrument that measures the angular distance between two visible objects. The primary use of a sextant is to measure the angle between an astronomical object and the horizon for the purpose of celestial. Otherwise, as a navigator someday, it is useful to us because the sextant was designed to define longitude by measuring the angular distance between the moon and a nearby star. It was also used on land and to find latitude at sea. A sextant is similar to an octant, but more powerful and precise. What is a celestial navigation? A celestial navigation, it is also known as astronavigation, is the ancient and continuing modern practice of position fixing using stars and other celestial bodies that enables a navigator to accurately. So, why is it important to us a navigator someday? In order to correctly calculate and tabulate positions by way of the celestial objects, it becomes necessary to understand the correlation between the angle of the object and its horizon with the vessel.
I will be reporting the sextant altitude by stars. The first thing you need to do is find the altitude of the stars of star Antares on 16th August 2008, when the sextant altitude was 35 degrees 28 minutes, height of I was 10.8 meters, and the index error was NIL. So the picture below is the highlighted numbers below. The 35.38 was the sextant altitude on August 16th, and the other highlighted is the height of the eye, 13 meters. So the solution is sextant altitude 35 degrees 28 seconds. Index error, none. Observed altitude DIP HOE, height of eye 10.8 meters. So the answer will be 5.8 degrees. 5.8. Apparent altitude is 35 degrees 22 minutes and 2 seconds. Total corrections are negative 1.4 meters. So our true altitude will be 35 degrees 20 minutes and 8 seconds. That's how you find the altitude of star Antares, sir. My name is Cadet Carlito de los Santos. Thank you, sir.
So I'm here to tackle about the sextant altitude by planets. So find the true altitude of planet Venus, 18th June 2004, when the sextant altitude was 46 degrees 17 minutes. Height of I was 7.9 meters and index error was nil. So as you can see in the picture below is the solution. So the sextant alt is 46 degrees 17 minutes. The true altitude is 46 degrees 11.5 minutes. So next is the observed altitude 46 degrees 17 minutes and the IP 4.9 minutes. So the apparent altitude 46 degrees 12.1 minutes. So the total corrections negative 0.9 minutes. The next is the apparent altitude 46 degrees 11.2 minutes and the additional correction is positive 0.3. So that's all. Thank you.
I'm reporting about sextant altitude by stars. So, first, find the altitude of stars revealed on 16 September 2001 when the sextant altitude was 36 degree 28 minutes. Height of I was 10.8 meters and index error was NIL. So, as you can see, there are highlighted numbers. First, the highlighted numbers was the sextant altitude on 16 September 2001. Then the second highlighted number is the height of I. It was 10.8 meters. So our sextant altitude is 35 degree 28 minutes. Index errors none. So observed altitude 36 degree 28 minutes. DIP is 5.8 minutes. Apparent altitude 38 degree 22.2 minutes. Total corrections negative 1.3 minutes. True altitude 36 degree 20.9